On this video, we're going to work through this exploring inverse functions worksheet together and try to reinforce some of the things that hopefully we got from the last lesson. So we can see that we have two functions, f and g, are inverses of each other if f of g of x is equal to g of f of x is equal to x for all values of x in their domains. So we're looking at here in that box a graph of f of x. So to find an equation, it looks like that's got a y-intercept of 1. Looks like it's going up 2 and over 1. So I would say we can have y equals 2x minus 1, or f of x equals 2x minus 1. Let me maybe call that f of x. So in the window, can we sketch the graph of y equals g of x, where g is the inverse? I'm going to make this red, so I'm just going to switch some points around there. So we know we have the point 0, 1, 0, negative 1 on the graph of f. So negative 1, 0 would be a point in the inverse. We also know we have the point 1, 1, and so that'll be a shared point, since when we switch the x and y, that will still be the same point. So that's going to be our graph of that. To find that inverse, remember we can switch the x and the y. So I'm going to say x is equal to, this is tough for me to do left-handed, so we have 2y minus 1, so that's going to be x plus 1 is 2y. So y is going to be either x plus 1 all over 2 or 1/2 x plus 1/2, either way. So I'm going to say g of x is 1/2 x plus 1/2. The coordinates of the y-intercept of f are 0, negative 1. So the coordinates for the x-intercept of g are going to be negative 1, 0. And the coordinates of the x-intercept of f is going to be, let's see, for f, if we put in 0 for the y and get 2x minus 1, then we're going to get 1/2. So the x-intercept is going to be 1/2, 0, which means that the y-intercept for g is going to be 0, 1/2. So how do the domain and ranges of inverses relate to each other? So the domain of f will equal the range of f inverse, or I guess we're calling it g. And likewise, the range of f will be the domain of what we're calling g, or f inverse. So which of the following is an inverse function? So we're looking to see, does it pass the horizontal line test? Since that does not, that will not have an inverse that is a function. Likewise there. And I think this one, I'm not sure, I think that's supposed to be y equals x cubed, or that's been translated up 1. So I think that is actually going to pass the horizontal line test, and so it will have an inverse that is a function, and so will D. Okay? So it says now, what can you say about the sign of the derivative of a function whose inverse is also a function? So we talked about this quite a bit. To have an inverse that's a function, it must be 1-to-1, must be strictly monotonic, and so that means f prime of x is either always greater than or equal to 0, or f prime of x is always less than or equal to 0. So based on that conclusion, what do we know about that? So this is kind of a tough one, so we try to find this derivative. We're going to get 3x squared minus 16x plus 16. Now we know this is a parabola, so in general we might think that the question is, does it lie always above the x-axis, or is it going to cross the x-axis somewhere? And it turns out that it does actually cross the x-axis. You could use your quadratic formula to find that, or I think I did a little guess and check, and I think I found that if you plug in to that derivative, if you plug in I think it's 2. So if we plug in 2, then 2 squared is 4 times 3 is 12, minus 32 plus 16 is going to be a negative 4. And we know that f prime of 0, we can see pretty easily, is a positive 16. So it's going to be increasing some places, but decreasing others. Therefore, the answer would be no, it does not have an inverse function. Now, use our calculator and the properties of an inverse function to approximate g of 10. So, where g is the inverse of that. So we're going to do this. First, they want us to graph this function. So we can, actually, let's come back and we'll do this one using the method that we talked about. So we know that f of g of x is equal to x if f and g are inverses. So differentiating that, we get f prime of g of x times g prime of x is equal to 1, which means that g prime of x, the derivative of the inverse, is 1 over f prime of g of x. And we want to find g prime of, I want to make that an equal sign, g prime of 10, which means we want 1 over f prime of g of 10. And remember, this is the hard part, is finding what is g of 10. So to find g of 10, we're going to make 10 equal to x cubed plus x plus 1. So that means 0 will be x cubed plus x minus 9. And this is not going to be pretty, so you're going to need to find your 0 on your calculator. And I believe when you do this, it's like 1.920 rounded to 3 decimal places. So that means that our derivative, see, we need to know what f prime of x is. That's not too hard. That's 3x squared plus 1. So we want here 1 over that, and we're going to go 3 times the 1.920 squared plus 1 goes into that denominator. I'm getting 0.0829. Yuck, not a very nice one there. Okay, so the next one's kind of interesting here. So it asks us to use the inverse features on your calculator. I don't know if you're familiar with this. It's kind of a cool little thing. But first we're going to graph f of x equals x cubed plus x plus 1 and its inverse on this window. So this window, if you look, has x min negative 8, x max positive 8, and a y min of negative 5, and a y max of positive 5. So if you put y1 equals that f of x, that x cubed plus x plus 1, into your calculator and graph it. So let me go back to doing that. When you do, I think you get something, whoops, that's going to look sort of like this. So there's our y equals f of x. Now there's a pretty cool feature on your calculator where you can get it to draw the inverse. So what the calculator actually does, it doesn't ever find the equation of that inverse, but it just goes through point by point and switches the x and y coordinates of each. So we want to go to the draw menu. So if you go second program, that's right in the middle there, and then you have to arrow down until you get to draw inverses option 8. Hit enter. And now since we have our function in as y1, we can go draw inverse and go variables, right arrow, enter, enter, and then it should show up on your calculator screen as draw inverse y1. Hit enter and you'll see it actually draw that inverse. So like I said, it's not going to give you the equation, but it's kind of cool to see I think it's kind of cool anyway, to see it actually do that, something like that. And the idea is you can see that they are reflections of each other in the line y equals x. So the next part here, if you're interested, you can try that on your own. This goes through how you can graph a function and its inverse using parametrics, but we'll do that more next year in BC Calc, so I'm going to skip that part and go to, instead, let's see where I want to pick it up right here on number 7. So can we use, not the method above, but the method that we have learned to find g prime of 2. So if you remember, we have g prime of x is going to be 1 over f prime of g of x. And so that means g prime of 2 is going to be 1 over f prime of g of 2. And finding g of 2 is going to be the challenging part there, because we're going to have to use our calculator, and we'll say 2 is equal to x to the 5th minus x to the 3rd plus 2x. Then I would make it equal to 0. Get x to the 5th minus x to the 3rd plus 2x minus 2 equals 0. And if you use your calculator and find the 0 there, I think you're going to get x is equal to 1. So we can then say that f prime of x is going to be 5x to the 4th minus 3x squared plus 2. And so we're going to get 1 over f prime of 1 is going to be 1 over 5 minus 3 is 2 plus 2 is 4, and that's going to be our derivative. So number 8, this is just walking us through again what we're doing. We know this is true because f and g are inverses of each other. And then we get to here when we differentiate both sides using the chain rule. And then we get to here by dividing through by the f of g of x. And so that's something you need to be able to do. Now the next two, these are actually some multiple choice questions from earlier AP exams where they're asking you to use this idea of finding the derivative of an inverse. So kind of interesting here, we know g of 2 is equal to 5, and we know that f prime of 5 is a half. How then can we find g prime of 2? And so the idea is here, they would have been given us that f and g are inverses. So that is that g of x is f inverse of x. So what we do is we know that our g prime of x is going to be 1 over f prime of g of x. So in this case, we want to find g prime of 2. So that's going to be 1 over f prime of g of 2. And since g of 2 is 5, we want 1 over f prime of 5. And we're told that f prime of 5 is a half. And so we're going to get 2. And so the answer should be then part A. And the next one, kind of similar. If h is the inverse of f, then what we want then is that h prime of 2. So here we get again that h prime of x is going to be our 1 over f prime of, I guess we're going to call that h of 2. And finding the h of 2 is the challenging part. So we're going to have to say 2 is equal to x cubed plus x. This would then be in a calculator active part of your test. So we would make it equal to 0. And then we would graph that and find the 0. And I believe you're going to get x is 1. You can kind of see that because 1 cubed plus 1 minus 2 is in fact equal to 0. So then we get here, we want 1 over f prime of, and that's going to be 1. And our f prime of x we'll have to find is 3x squared plus 1. And then plugging in 1, f prime of 1 is going to be 3 plus 1 is 4. And so this is going to become 1/4. And that's going to be option B. Very good.